Hi everyone and welcome back. We are now heading into the last couple weeks of the semester. We're in week 12 here, and today's topic is going to be something called analysis of variance. But before I get there, I just want to go over the schedule for the last couple weeks of the semester since we are almost there. So this week we'll be doing analysis of variance, and we'll have problem set number 11 due at the end of the week, so just a regular week. Next week, Thanksgiving. No class activities or problem sets or anything that you have to do next week. We'll be back the week after that, which will be the week of November 30th going into December. Our topic will be chi-square and correlations, and problem set 12 will be due. You may remember there are 12 problem sets total in the class, so that will be your very last one. Week 14 is a lecture that I'm calling Who Cares About Statistics, where we will talk about some applications of everything we've been doing, and especially things to look out for, like in news stories about statistics where things might be misleading or whatever. So that'll be that lecture. And for that lecture, we have a makeup problem set. With this makeup problem set, if you complete this one, you can replace any earlier problem set score throughout the semester. So if you missed one, you do the makeup problem set, it'll take place of the missed one. If you did all the problem sets but got a low score on one of them, you can do this makeup problem set and it will replace that low score. So just a heads up, that is what is coming up next. All right, so now I'll get into the topic for today. And analysis of variance is a statistical test that lets us compare 3 or more means to each other. So, for example, with what we're going to do today, you'd be able to answer questions like, are attitudes about the death penalty different or the same among people who are white, black, or Asian? So there you have 3 different groups and you're comparing them to each other. Do drug offenders, violent offenders, or sex offenders have higher recidivism rates? So again, we have 3 different groups and we're trying to compare them to each other to see if they're the same on some measure or whether they're different from each other on that measure. And so far in doing hypothesis testing, we've only talked about t-tests. And last week we talked about how you can use a t-test to compare 2 groups to each other. But the problem with using t-tests is that there isn't a version for 3 groups. So you can only compare 2 categories at a time because you're looking at that difference in means, right? So you can only subtract one thing from another thing to find a difference. And if you were to do multiple t-tests, so for example, compare death penalty attitudes among white people and black people and Asian people and white people, then you get more of what are called false positives. And at the end of the hypothesis testing unit, I'm going to talk a bit more about what false positives are and why you want to look out for them. But for now, just take my word for it that we want to avoid that. So analysis of variance is something that you'll use if you want to look at differences among groups of 3 or more. So when you have 3 or more samples and you want to compare their means. Analysis of variance. All right, so like any other hypothesis test, analysis of variance, which is typically called Anova, and that's what I'm going to call it from here on out, you'll be writing null and alternative hypotheses. And with Anova tests, the null and alternative hypotheses are always going to be exactly the same. Your null hypothesis is that all of the populations you're interested in have the same mean. And so this could also be written like this, where the mean for one population, the mean for 2 population, the second population, the mean for the third population, and 4th, 5th, 6th, so on, however many populations you have, we're saying that our null hypothesis is that they're all the same. So as an example, if you were looking at death penalty attitudes among those different groups, your null hypothesis would be that white people, black people, and Asian people have the same attitudes about the death penalty. That's it. We're talking about the different populations. And so with the hypothesis test, we're going to be looking for evidence that could potentially disprove our null hypothesis and give us reason to believe that an alternative hypothesis would be true. Your alternative hypothesis, as usual, is going to be that all populations do not have the same mean. So your means for all the different populations you're looking at are not all exactly the same as each other. So in other words, they're different. So an alternative hypothesis in that example would be that, black, white, and Asian people don't all have the same views about the death penalty. One thing to look out for, though, that people always do, so I'm going to warn you to not do it, do not write this hypothesis as mean for 1 is not equal to the mean for 2, which is not equal to the mean for 3, which is not equal to the mean for however many groups you have. The reason for this is that our only hypothesis here is that all populations are not exactly the same as each other. But this includes a lot of different possibilities, such as the possibility that 2 groups are equal to each other, but 2 groups aren't. This group is equal to each other, this one, but this one is not equal to this other one. So there are lots and lots of different ways that you could have all populations not being all exactly equal to each other. And this is going to be important a little bit later in interpreting the results of the hypothesis test. But for now, I'll just say keep in mind that saying that all the populations are not exactly equal to each other doesn't mean that some of the populations aren't equal to each other. Okay, so now I'm going to talk through some of the components of an Anova test. Specifically, an Anova test is a test that compares variation between groups to variation within groups. And we do that using something called mean square. And a mean square is just a measure of how variable something is. So measures of variation, as we talked about at the beginning of the semester, talk about how spread out observations are or how close they are together. Like I usually do with this kind of thing, I'm going to go through some of the terms first, then I'm going to go over to the document camera and give some examples and talk about how they're used. So bear with me here, I'm just going to talk through these terms first, and I assume they won't make as much sense as they will after we've gone through the example. But here we have our mean square, which are measures of variation. Your mean square between groups gives you a sense for how similar your different samples are to each other. In other words, if you're doing analysis of variance, you're comparing multiple samples to each other for 3 or more groups. Your between groups mean square is a value that's going to tell you how close or how spread apart your different samples are to each other. And typically we'll be doing this by looking at the sample means. Your within groups mean square tells you how similar the members of each sample are to other members in that sample. So if we were looking at white, black, and Asian samples, you're going to have mean squares that tell you in general how similar are your white people to each other, in general so how similar are your black people to each other, and in general how similar are your Asian people to each other. And these two values, your within groups mean square and your between groups mean square, will be used to calculate something called an F statistic. And the F statistic is the test statistic for an Anova test. It's larger when there's a lot of variation between groups. So it's large when your groups are very different from each other. And it's large when there is very low within group variation. So in other words, you have a large F statistic when members of each group are similar to members of, other members of the group they belong to. And so like I said, I'm going to go through the terms and then I'm going to hop over and describe what these terms mean a little bit better.